Anyway, fair enough. So welcome to the November edition of the RASC Ottawa Centre's monthly meeting. Big welcome to all of you. I'm feeling particularly good about tonight's show. We've got a very full program. Next, please, Chris. Okay, tonight's program, we have Gary Boyle doing Ottawa Skies. We haven't had that segment done for a couple of months now, so a little bit of an update on what's going on in the skies here. Followed by our president, Al Scott, doing the 10-minute astronomy news. Simon Hanmer is back with talk about one of the larger geological features on Venus. Melanie Hall from the host, our museum host, is here to talk to us about the museum's astronomy programs. We have a couple of observations this evening, and then after the break, Al Scott will be handing out more of the membership recognition pins. We're gradually working down decade by decade. Those of you who have been attending lately, we've done, what was it, the 60s, 50s, and I think we're into the 40s this time around. So he'll be talking to you about those pins, followed by Bob Olson with a quick update. He just got back from the Chiefland Star Party, and he's got talk about the trip and also some nice images to go with it. Jeff Cohill will be talking to us about indoor observing, and Eric Cuila will be talking to us about sort of continued observations regarding St. Veronique, which was thought to maybe be an impact site, but I gather maybe it's not anymore. Anyway, without further ado, next please. So we start off with Ottawa members in the news, and it seems to me that every month we have more than we had the month before. The center seems to be getting an awful lot of recognition these days. So to start off with, Jacob von Chorus has this lovely view of the Pleiades, published in the Gallery of Sky News. Next, Glenn Ledrew, in his series of articles that he's been doing, you'll probably remember he did a couple of articles on supergiant stars, and he's now speaking about the Perseus Arm. Next after that, Gary Boyle got some recognition in the local media for his photographs of Aurora from just a few weeks ago, I believe. Very good coverage, a couple of images and an article. Next up, Deborah Cervolo is recognized for her article in Sky and Telescope on use of filters in astro imaging. And lastly, Sanjeev Sivararasa has today's paper, I believe, has got a review on his exhibition that's going on at the gallery right now. So if any of you are not yet aware of Sanjeev's exhibition, the Cube Gallery, head on down. Some very nice images, a very worthwhile show to see. Next, please, Chris. Okay, so we'll start up with Gary Boyle. Speaking to you about Ottawa Skies. Gary.
Just came in from the lobby taking all your money. Last chance for dinner tickets, folks, so please see me during the break or after the meeting. You actually going to trust me with this? Next slide, please. I usually go 18 ahead. Well, we call it now the cloudy report rather than clear skies. For the month of October, we've had about 15 cloudy nights, as I put cloudy, rain, or snow, because that'll be coming by next month. So we had 7 clear nights. Any observations? Anyone use those nights to photograph or observe? Or excellent, great, sweet, great. Okay, next slide, please. Just a few things to a few Kodak moments this month. Right now, for the next 2 weeks, right till about the 15th of the month, you're going to have Venus and Mercury trailing together as a pair in the west, right after sunset. They're actually going to play tandem. And then after a while, Venus will continue up and Mercury is going to slide back down toward the sun. Next slide. Yes, good old Mars, the red planet, will be flying just above Regulus, which is Regulus over here. Here's the Leo, the sickle of Leo. So the red planet traverse across for about 4 nights from the 8th to the 12th. And as you can see now, Saturn is rising early. So this is a few hours before sunrise. Next slide. And lastly, we have Orion the Hunter, great winter constellation. So pretty well this next few weeks will be your last chance before digging out that shovel. Who started polishing their shovel? I have. We don't polish mirrors now, we polish shovels. And speaking about observing, I checked the clear sky chart for tomorrow night. Very high transparency, so it should be great for the moon and planets for photography or observing period. And the Aurora Borealis, hopefully this weekend, sun's very active. Spot number 1339 is about 4 times the size of the Earth in width, about 6 times as long. So it's a massive sunspot. Some X flares are now coming out of the sky. So keep looking toward the skies this week. Keep checking spaceweather.com, and especially the Corona Oval that's on the side. And I think that's it. No. Clocks go ahead, clocks go back 1 hour Saturday night, so an extra hour of observing. But remember too, when you transcribe from Universal Time to Ottawa time, don't forget now, moves to 4 hours when converting various events in the handbook or from Sky and Telescope.
You got it the other way.
Is it 4 hours now? Okay. No, don't even bother. Don't even bother. I was just checking if you guys were awake or not. This was a test. You've all passed the test. Sweet. And I think that's it. No, should a couple more things. Just the planets where they are. Self-exclamatory. Of course, Jupiter's out all night long. Just fantastic views of Jupiter, being very nice and high in the ecliptic. Saturn's just starting. And then lastly, we have the various lunar phases. The Beaver Moon will be on November 10th, the same night as the Leonid meteor shower. Only about 25 meteors per hour, but a full moon being out will not be too advantageous.
What's a beaver moon, Gary?
It's a moon for the beavers. Well, just like we have a hunter's moon, only beavers can observe. Now, we have a hunter's moon, a harvest moon, but every month in the Farmer's Almanac, there is a moon. In fact, on the RASC calendar, right at the bottom for every full moon, it's marked what name it's actually called. As I mentioned before, we have 2 weeks from tonight, we will have Dr. David St. Jacques, and I did get the confirmation today he will be attending. It was touch and go. He might have been in Russia for training, but I finally got the call today, and he will be at the dinner. So as I said, $14 a ticket. I'll be in the front here during the break or in the lobby after the presentation. One thing that I was just attested to is the usual parking lot that we park in for the previous years. They're starting to put a building up there now, so you're going to have to put one parking spot a little more to the east or north, but not too far. Great. And that's all, folks. Give me your money. I want your money.
Thank you, Gary. Next up, our President Al Scott to talk to you about astronomy news.
Good evening, everybody. Tonight, I'd like to talk to you a little bit about one particular observatory. It's an orbiting space observatory. It's Herschel, and some of the discoveries that are coming out of this long-wave infrared telescope. There's a picture of it right there. Canada actually has a link into this. We, ComDev, built part of one of the instruments. There's an instrument on this called Hi-Fi, which is a heterodyne instrument for far infrared detection. Heterodyne means it's basically taking the photons that it observes and making an interference pattern with a stable frequency that's being generated inside the spacecraft. And ComDev in Cambridge actually built the stable frequency generator that this thing uses to detect things in space. So the first story is an interesting one. This is Comet Hartley, pictured here, 103P Hartley 2. And we have right there, this is the orbit of Comet Hartley. And it's a Jupiter family comet. And so this is it in relation to the innermost 5 planets of the solar system. And the comet has made its latest perihelion passage on the 28th of October 2010, and it actually passed within 0.13 astronomical units of the Earth on the 20th of October that year. This was the comet's closest approach to our planet since it was discovered in 1986. So it's a short period comet. It comes around relatively frequently. On this occasion, the Herschel telescope observed the comet and obtained highly accurate images and spectra in the far-infrared portion of the electromagnetic spectrum. Now this is an image of Comet Hartley on the right, taken by the Epoxy spacecraft of NASA. It actually flew right up close to the comet itself and has these pictures of jets coming out of the nucleus, of basically ice sublimating as the sun hits it and creating this big tail of the comet, and the sun eventually eats it away over time. Now the inset in the middle there is the spectrum. This is the spectrum taken by the Hi-Fi instrument, and this is an image of it taken by the PAX camera on Herschel. So there's a couple different instruments on the Herschel telescope. So those two lines that you see in the spectrum are two different isotopes, or isotopologues as it's called, of the water molecule as seen in the comet itself. So all the water molecules, you can have heavy water, you can have light water. And what this thing is doing is measuring the lines, and this is just overlaid from two different frequencies. Each one has a different frequency in the infrared that you can observe it at. The blue curve has two normal hydrogens and one heavy oxygen atom in the molecules. And the red curve is a weaker signature of a semi-heavy water, which has a hydrogen and a deuterium and a heavy oxygen. And what this tells us is it gives us an idea of the ratio between hydrogen and deuterium in the comet itself. And this is interesting because we can link together where things were formed based on this ratio of hydrogen to deuterium. And different bodies in the solar system have different ratios, and it reflects their history and when they were formed in the initial solar system. From the relative abundance of these two molecules, astronomers can infer the deuterium to hydrogen ratio, and by comparing it across all these bodies, you can actually compare it to the water ratio in Earth's oceans and find out where they came from, because it's always been a problem. The Earth, from the theories, the Earth when it formed was hot, and all the water would have probably boiled off. So where did the oceans come from? And so people have been for many years wondering where the water in their oceans came from. And people thought, okay, well, it's got to have come from the comets because they're made of water. But earlier on, people have taken these measurements on long period comets from the Oort cloud, and the deuterium to hydrogen ratio didn't match. And so from that data, people thought, well, it actually can't be the comets. And this actually is a graph of the deuterium to hydrogen ratio of various bodies that have been looked at. On the bottom, there's a line called ISM. This is the interstellar medium deuterium to helium hydrogen ratio. So out in space, we assume that the solar nebula had this ratio. And you see some of the giant planets also have very similar ratios to the interstellar medium. But then you have these smaller objects that have higher deuterium as a function of the number of hydrogens. And why is this? Well, what we think is that because hydrogen is a little bit lighter than deuterium, some of it has escaped preferentially. Hydrogen has escaped from these bodies over the lifetime of the solar system. And what we have here is, here's the line for Earth, and we found that the carbonaceous meteorites have roughly the same ratio, and people were thinking, okay, so it must have come from the asteroids. All the water in our oceans must have come from the asteroids, because it didn't match all the comets we'd measured to date. But all the comets we'd measured are from out in the Oort cloud. And this data from Hi-Fi is the first one to find a comet that actually matches the content of Earth's oceans. So now we have data that the oceans of Earth probably came from the Jupiter family comets, which is really neat. This is a very new discovery. My second item of news is also on water. Using data from the Herschel Space Observatory, astronomers have detected for the first time cold water vapor enveloping a dusty disk around a young star. The findings suggest that this disk, which is poised to develop into a solar system, contains great quantities of water. Again, these are new discoveries. Back when I was a student, people thought that it was very dry out there because we hadn't been able to see the water. We hadn't had you can't see water through our atmosphere because our atmosphere is full of water. So you need to have telescopes out in space, and these long wave infrared wavelengths are just starting to detect water everywhere in the universe. So scientists previously found warm water vapor in planet-forming disks close to a central star, but evidence for vast quantities of water extending out into the cooler far reaches of disks where comets take shape had not been seen until this observation. The more water available in disks for icy comets to form, the greater the chances that large amounts eventually will reach new planets through impacts. The star with this waterlogged disk, called TW Hydrae, thus the title, is 10 million years old and about 175 light years from Earth in the constellation of Hydra. TW Hydrae is an orange dwarf star, somewhat smaller and cooler than our sun. And the giant disk of material that's pictured here in the artist's conception has nearly 200 astronomical units in size. And over the next few million years, astronomers believe the matter in the disk will collide and grow into planets, asteroids, and other cosmic bodies. And dust and ice particles will assemble as comets. So the frigid, watery haze that has been observed by Herschel is thought to originate from these ice-coated grains of dust in the disk near the disk's surface. UV light from the star, ultraviolet, is actually causing some of the water molecules to break free of the ice and creates a thin layer of gas with the light signature that can be detected by Herschel, again with a hi-fi instrument in the heterodyning. So as the new solar system evolves, icy comets are likely to deposit much of the water they contain on freshly created worlds through impacts over the period analogous to our solar system's late heavy bombardment, giving rise to oceans. There's thousands of oceans worth of water in this disk. So some really interesting stuff coming out of Herschel right now on the water content of the universe. I think that's the end of that. Again, those are two different isotopes. Any questions on that? Okay. So next, I've got to put on my other hat as telescope loan librarian for the club. We haven't advertised the telescope loan library in a while, and I thought of putting a slide up here. There's a couple. There's a new policy that I'd like to introduce to the membership. If you've known, we have a library of telescopes available for rent for any members. We're starting a new policy. What we're going to do is we're going to allow you to pay for up to 4 months, and then beyond that you can just hold on to the telescope until someone else asks for it. Because we have a lot of telescopes that are just sitting in my basement. And although it's great to have a telescope to just roll out whenever I need it, it would be better if the members had access to them. And this also opens up the job of telescope loan librarian to people who don't have much storage in their basements, which may be one reason we haven't been getting a lot of volunteers. So this is a great opportunity for you to have your own RASC loan telescope indefinitely. As a corollary to this new policy, we're requesting some eyepiece donations. All of our scopes are 1 1/4 inch. We have lots of 20 and 25 millimeter eyepieces. We don't have very many high magnification or wide field ones though. So if you have any old eyepieces lying around that you don't use anymore and you'd like to have someone else use them, please feel free to think of us as a receptor. Okay. Thank you.
Thank you, Al. Next up, Simon Hanmer will be speaking to you about one of the larger geologic features on Venus and some ideas about it.
Listening to planetary geologists, you sometimes get the impression that there's a bit of a competition going on among them to find the biggest whatever in the solar system. As I've discussed with you in past years, Mars leads the pack for the largest mountain, well, it's really a volcano, and the largest valley. And Jupiter's ice moon Callisto and our own moon are in competition with each other for the biggest impact feature. Now, in a recent paper published last year in the scientific magazine Geology, scientists think they've discovered the largest geological bump in the solar system. Next one, please, Chris. Now, when I say bump, the technical term for it is actually a tectonomagmatic feature, or a dome, but we'll come to that. Now, ever since the Magellan probe imaged the surface of Venus in the mid-1990s using radar to peer through the clouds of the thick Venusian atmosphere, planetary geologists have been able to make out a number of first-order topographical features. And using a combination of high-resolution images and gravity calculations, they've started to come up with some interesting interpretations about how some of these features actually formed. And in doing so, they're coming up with geological stories that show how some of these features actually formed either together or at least in rapid-fire sequence, such that they're probably genetically related to a common cause. And it's the cause I want to talk about. Now, the very obvious circular feature here in the southern hemisphere of Venus is called Artemis, and it was already identified in the first Magellan images of the mid-1990s. Now, geologists have been arguing about just how Artemis formed ever since its discovery. But the recent paper in Geology magazine suggests that it's actually just a pimple on a much larger geological feature. And if they're right, if they're correct, this would dramatically narrow the options for its origin. So let's take a look at the evidence in favor of what we can call loosely the greater Artemis, and what it tells us about the Venusian geological evolution. Now remember that, as I told you a number of years back, Venus has been completely resurfaced by planet-wide volcanic eruptions during the past billion years. There's some debate over exactly when the main resurfacing occurred. And some say that such volcanism might even be continuing to this day. So my point is that by the standards of our 4.5 billion year old solar system, the geological features of the greater Artemis that we'll look at here are relatively young. And it shouldn't be a surprise, the greater Artemis will actually be something like this, but I'll show you. Next one, please, Chris. Now, this is about as natural, in inverted commas, a view of Venus as one can get. This is a radar image. The radar can penetrate the cloud, and it can see topography in some pretty good detail. The white features, here, and then across here as well, those are areas of very strong radar reflection, and it's due to a surface coating of fool's gold. It's not gold. More technically, it's known as iron sulfide or pyrite. Now, notice how this forms a broad east-west band with large dense patches to the west here and up here to the north, and then this squiggly stuff over there. And there's this very obvious circular feature round about the midpoint here. That, of course, is Artemis. That gives us some kind of orientation. By the way, Artemis is about 2,100 kilometers across. Next one, please, Chris. Now, this is a false color image of Venus. In other words, it's been photoshopped. And it picks out rough differences in geology. The tan and white areas here are quite distinct from the blue and green areas. And if you get your bearings, here's Artemis there. And we can see the same patches to the west and the north that we saw on the previous image. Now keep these in mind, these large patches, as we'll come back to them throughout the talk. Next one, please, Chris. And this is a different false color image of Venus, this time picking out rough differences in topography. Yellowish colors are high ground, so up here, here, and then across to there. There, of course, is Artemis. And the greenish colors are generally low ground. Now, notice that Artemis actually lies on the south side of a band here of relatively high ground. And with those two patches to the north and to the west, and then here's that squiggly stuff leading over to yet another patch further over. And those are squiggly strands I'll come back to in a moment. Next one, please, Chris. So let's put all these features together now on a single radar image. And if we do that, we can see here's the circular feature Artemis. And it's part, really, of a larger highland region, which is all of this, which is known as Aphrodite Terra. And the word terra here just means ground. Aphrodite Terra is made up of Ovda, Thetis, and Atla Regio. And Regio here just means highland. But you can see these are the patches that we saw on the previous false color images. Now, Ovda and Thetis are neighbors, obviously. And Atla here is linked to them through this corridor here of rather complex-looking rift valleys, which are referred to here as the Diana Dali, the two names, the Diana Dali Chasmata, and Chasmata just means chasms. In other words, valleys, that's what it means. So remember, given that Artemis is over 2,000 kilometers long, you can work out for yourselves practically how long that is. Next one, please, Chris. So what exactly is Artemis? Well, this map here shows Artemis down there. There's the two patches of high ground. There's Ovda Regio and there's Thetis. And in fact, what it is, it's a round feature, and it's called the feature itself is referred to as Artemis Corona. No, it's not named after the Mexican beer. It looks like a moat, and that moat that surrounds it is called Artemis Chasma. Yet again, that word for valley. Next one, please, Chris. Now here's a more photographic close-up of Artemis. This obviously is Artemis itself. These round corona features are characteristic of Venus, but this one is by far the largest and the most spectacular. The moat-like feature that surrounds it is a circular valley. It's 25 kilometers to 100 kilometers wide, depending on where you are, by about 1 to 2 kilometers deep. There are lots of theories as to how it might have formed, and these range from an impact feature to the product of magma welling up from deep inside the planet. And some geologists have even suggested that it formed by plate tectonic processes, but this does not stand up very well to scrutiny. However, all of these hypotheses are hampered by the fact that such corona features do not occur on the Earth. They're unique to Venus, so they're difficult to test, even by simple comparison to knowledge of our own planet. Oh, there are round structures on the Earth bounded by circular depressions, there's no doubt, but there's nothing quite like this, and certainly not formed on the surface like this was, and certainly not of this size. Now, at the beginning of the talk, I mentioned that if Artemis really is part of something much bigger, geologically speaking, then this might have repercussions for theories about its origins. So let's now pull back, and let's look at the really big picture of this part of Venus. Next one, thanks, Chris. There we go. Now, the paper in Geology magazine proposes that everything we've looked at so far is, in fact, a part of an even larger geological feature that we can refer to colloquially as the Greater Artemis. So there's Artemis itself, and we're going to be talking about a feature of this kind of size. Now, the white circle indicates the approximate outer limit of Greater Artemis. That's about 13,000 kilometers across. You can see that this coincides with the approximate outer limits of a set of red concentric lines. You see them here? And then they're really very pronounced down here too. Now, what exactly are these things? They're referred to as wrinkle ridges, but it's not the same thing as the wrinkle ridges you hear about on the moon. Let's look at some examples from north of Ovda Regio, and Ovda Regio is this one here. Remember, there's Ovda, there's Thetis, and there, over here, is Atla Regio. Okay, next one, please, Chris. Now, what I want you to focus on is this over here. See how there's this hairpin bend? Oh, sorry, there's a hairpin bend there and a hairpin bend there. Now, a geologist will immediately recognize these hairpin bends in layering, in geological layering, as folding. And folding of a layer implies that the layer was shortened, more or less, perpendicular to the traces of the fold. In other words, it was squeezed by being pushed along a line like this. However, not all folding on Venus is as easy to see and identify and to decipher. Next one, please. Much of it looks like this. When the shortening gets locally intense, the hairpin bends disappear. And what you end up with is a series of simple stripes without the actual bends. But to a structural geologist, they clearly represent very tight folding of volcanic layers close to the Venusian surface. Next one, please. Now, in addition to the concentric folds, you can clearly see a set of radial lines. You can see them very well down here. They're in black here, by the way. And then here they are again, coming out like this, these radial lines. These span a circular area about 12,000 kilometers in diameter. And they all seem to point inwards towards Artemis. Now, again, a geologist would immediately recognize these as a giant swarm of radial dikes, a feature that's not uncommon on Earth, but is rarely this big. So what is a dike swarm, and what does it imply? Next one, please, Chris. Dike swarms are, in reality, swarms of cracks in a planet's crust that fill with molten magma under enormous pressure. That magma is trying to rise up towards the planetary surface. Some terrestrial examples are shown on the right-hand side. Here's a nice big Canadian one, by the way, coming from the Canadian Arctic right the way down to Lake Superior. And the block diagram over here on the left-hand side, this indicates that such swarms usually form as the planetary crust is being extended. It has to be extended to accommodate the injection of the liquid magma. That's the complete opposite of the shortening implied by those concentric folds. Next one, please, Chris. Now look at the main band of highlands down through here, going from Ovda Regio out to Atla Regio. And notice the speckle pattern that's drawn through here. It's in a sort of a clear band, an east-west band, if you will. And it includes here the rifts of what I referred to as the Diana and Dali Chasmata system. Next one, please, Chris. This is a photographic close-up of the Chasmata system. From here to here, there's Artemis, by the way. This picture is 7,500 kilometers across. Now notice how intricate the Chasmata system is, all these various strands. Each of these radar bright strands is a rift valley, and rifts, as in our own Ottawa Valley, indicate extension of the planetary crust at a high angle to the valley trend. In other words, there's the valley trend, and you've extended in that direction there. Now let's go back to the big picture and put these rifts into context. Next one, please, Chris. See how the speckled band here cuts right across Ovda and Thetis Regio, cuts right across like this and just keeps on going. Until you come to Atla Regio, right there. And then something rather remarkable happens. It actually divides into 1, 2, 3 branches. Geologists instantly recognize this. Oh, by the way, I should have mentioned that the branches come together dead in the dead center of Atla Regio. And geologists instantly recognize that this is what we refer to as a triple junction that forms as the planetary crust is stretched and split above a rising dome. If a dome is rising like this, then the crust above it, the skin above it, must stretch. You've gone from this to this. In other words, in the case of Atla Regio over here, that rifting, represented by the speckle pattern, is related to the formation of Atla Regio itself as a dome. While in the case of Ovda and Thetis Regio over here, the rifting, indicated by this speckle pattern through here, ignores the highlands completely. It just cuts right across them. And what that tells us then is that the rifting here is younger than the formation of these two highlands. Next slide, please, Chris. All right, I hope you're beginning to see where I'm going with this. We now have the outline of the geological story that evolves through time. This is a Mickey Mouse sequence of what I'm going to be showing you. And so it reads from here, the oldest, to this, the youngest. The greater Artemis feature appears to be a gigantic dome in the Venusian crust that formed above a gigantic plume of hot material that rose from deep in the planetary interior. So here's, in Mickey Mouse form, there's the plume coming up, and the dome is going to form here. As it did so, smaller domes began to form above the plume in the early part of the story, giving rise to Ovda and Thetis Regio. Now, that would be somewhere around about there. It's slightly out of sequence. I would have preferred it to be drawn there, but unfortunately, I'd grabbed this diagram here. Anyway. As the rising plume grew, a progressively larger volume of the Venusian crust was induced to participate in the dome above the plume. And you can see this represented here. The plume starts to form a dome here, and the dome then grows and grows and grows, getting larger and larger, involving more and more crust. As that dome grows, so the outer crust of the dome begins to stretch and break, and it forms a giant radial dike swarm centered around the Artemis corona. So that's what these things here represent. This is the radial fractures as this dome is growing larger and larger and larger, and they're focused on that point there, which would represent Artemis itself, if you will. At the same time, around the periphery of the giant dome, the planetary crust begins to buckle because it's sliding off the topography that's being built by this rising dome. And that's what's represented here by these red concentric lines. And it forms these concentric folds that as they become progressively tighter, they're transformed into stripes, which are then called wrinkle ridges. Now, eventually, the top of the dome rises so much that it splits along an east-west axis, which isn't directly represented here, but it would be like this, there, or there. And it splits along an east-west axis, except in the east, which would be represented by this here, this here, this here, where you've got a triple junction which forms over a new, even younger dome, which we now see as Atla Regio. And that would therefore be one of the youngest features in the evolving Greater Artemis structure. So now that you've got the entire Greater Artemis story, let's go back to the big map of Venus and briefly summarize how that story works. So here we are. We've got a structure this large, which is going to form as this plume comes up through the mantle of Venus. It's coming up around about there. As it comes up, it domes the crust on this kind of scale. The crust begins to split along these radial dikes. As the topography grows, so the outer layer of the crust begins to slide off away from the rising center of the dome and forms these folds around the outside. Parasitic, if you will, like pimples growing on the larger dome, you initially get Ovida Regio and Thetis Regio begin to form as smaller domes on the big dome. And then the big dome itself begins to split along the Diana-Dali chasmata. As that rifting is occurring, so over in the east, you now get a third, even younger dome, the Atla Regio, and the rifting here now responds directly to the fact that a dome is rising up under the rift. So the rifting here is the same age as the dome here, whereas the rifting is younger than the doming here. So there's your overall story. Finally, what do we know about what caused the Greater Artemis feature to form? At 13,000 kilometers, it is the biggest dome of its kind, or the biggest dome full stop, anywhere in the solar system. There is nothing of this kind of size. Frankly, they don't know too much. There's some speculation that the trigger could have been a major impact from outside that might have catalyzed the upwelling in the planetary interior, but we'll have to wait and see if that idea actually has any legs. What we do know, as I say, is there's nothing like it anywhere else in the solar system. Thanks for listening, and happy year of the solar system.
Thank you, Simon. Oh, thank you, Simon. And to just kind of wrap things up, our next presenter is Melanie Hall from the Museum of Science and Technology to talk to us about the museum's astronomy programs that are upcoming over the coming year, and also some new policy changes with respect to volunteering. Welcome, Melanie. Is she? There she is.
Thank you. Thank you. So thank you for having me at your meeting. This is my first RASC meeting, and I'm really quite enjoying it so far, so thank you for having me. I'm right here at the Museum of Science and Technology. I'm an education and interpretation officer. Essentially, I'm in charge of all the astronomy programs at the museum, so I'm here to tell you about what we have. But also, since that would only take 5 to 10 minutes, I thought I'd add in a little bit more. So today, actually, before I forget, at the back, as you go out for your break, we've got pens for everybody, because this is National Science and Technology Week. Has anybody heard of National Science and Technology Week? We had Science Fun Fest a couple of weeks ago. Was anybody at Science Fun Fest? It's fun. We had lots of RASC members at Science Fun Fest. It was really fun. Anyways, it's part of a national campaign, and we're giving out some pens for you guys today. So yay, free pens. Yeah. More than one if you'd like. So yeah, I don't really remember this order of my slides, but we can probably go to the next one. So I was going to tell you, if I move over here and talk, can you guys still hear me? No. Oh. Okay, I'll stay put. So I was going to tell you a little bit about myself before. So I actually studied astronomy at Queen's University. I was there. Okay, thank you. So I'll tell you a little bit about why I'm here and how I got here, first of all. So I studied for 6 years astrophysics at Queen's University. So I studied galaxies, disk galaxies in particular. I put up the name of my thesis, mostly, you maybe can't read it, but it's for me, because I can't remember the name of what it was. It's really long. It's called An Investigation of the Sloan Digital Sky Survey Imaging and Multiband Scaling Relations of Spiral Galaxies. And then there's brackets, in brackets with known dynamical information. So it's kind of it's interesting for me. It's not interesting for everybody. It's going to be published next month.
Basically a spinny PhD.
Yes, very spinny. So I study galaxies like this one. So this one has a lot of dust, so it's a little bit harder to study. But it's essentially, you can measure the rotation velocity of galaxies as they're rotating, these, at least disk galaxies, their brightness, as well as the radius. And these three properties in disk galaxies are all very much related to each other. And so we're trying to, the baryonic, or the Tully-Fisher relationship is something that comes out of this, which is really important in finding distances to galaxies. So in doing this, I was really lucky to have a great advisor who's at the bottom here, on the bottom right-hand side. It's Stefan Coteau, and he took us to Hawaii in this particular instance. This is on the top of Mauna Kea. There's Gemini in the background. There's the 2.2 UCART telescope in the 2.2 Hawaii telescope in the back, and we're standing on the catwalk of the CFHT telescope. So I was very lucky that I got to go and do some training at both of these facilities here. Above is at the VLA. I think it's still called the VLA for now. They're renaming that telescope, and this is where Jodie Foster actually found aliens. This is where she discovered alien life. So that's me recreating Jodie Foster. And so while I was at the Queen's University, I worked with the Kingston Astronomicals, the Kingston RASC branch, and did a lot of stuff at the Queen's Observatory. So I ran the observatory for 2 years there, and this is me with our, it's a rather large telescope, I guess, here in the left-hand corner. And so we ran programs just like I run here at Queen's. So now that I'm here, next slide appears. This is our telescope at the Helen Sawyer Hogg Observatory, which is right outside. Some of you may have been there before. So now I run all of the astronomy programs, as well as some of the school programs. So if you've got kids elementary age, maybe they've been here for a field trip, the museum organizes, I think, about 3,700 school children come here per year on their field trips with their family, with their schools. And we take care of them, as well as summer camps and astronomy programming. So luckily, because I have an astronomy background, I was given all of the programs, which is really amazing because we've got this great facility outside. This is the 15-inch telescope. Here, I'm talking to some people at the Teacher Institute. We have a summer institute for elementary teachers at the museum that we started last year. We gave them a nice tour of the telescope. So I think the next slide should, again, the telescope, good. So it's a 15-inch refracting telescope. It's the oldest in Canada. Well, it's the largest in Canada as well. And we still get to use it, luckily. So it's an artifact of the museum, but luckily we're actually allowed to not only use it and observe through it, but recently we've been able to make some changes to it. So this top photo over here, image credit is Brian McCullough took this photo on one cold night in, I think, September, this September. And this is Tim Cole and Paul Coninger, who are members here. Maybe they're here tonight. And we're installing or preparing for a new video observing system at the museum in the telescope. So essentially, we're piggybacking a second telescope on top of this larger 15-inch, so we have to get permission from conservation, but they really liked our idea. And what will happen is with that second telescope that's on there, we'll put a digital video imaging system that'll be projected onto a screen on the wall of the observatory. So when you stand there waiting in line to see your image in this big telescope, you'll be able to see images of, say, Jupiter right now. So we do some really good engineering sessions here, and it should be ready to work for our next observing session, which is November 18th. But I noticed you guys have quite a nice dinner going on November 18th. So if you're wondering when our observing sessions are, we do have some brochures, and I'll talk about them in a little bit as well. So we can go to the next slide. So here are the dates. So it's our free stargazing program that we have about once a month. So here we had one on October 21st. That was when Terence Dickinson came to visit. We had some RASC members out as well. It was cloudy, so we didn't get to do much, but we have the observatory open regardless. The next one is November 18th, 9 p.m., and then December 21st is the winter solstice. I think it's a Wednesday. So it's in the middle of the week, but it's winter solstice, and we're looking for volunteers And if you'd just like to come out as a guest and do some stargazing, that's great. So those are free, and there's a lot of 2012 dates in there as well. There's brochures here and online if you're curious about the exact dates. What else do we have? So this is our new 2012 programming, and there's a new program that we've got called Astronomy Cafe for Adults. So this might be more up some of your alleys. So we have astronomy educators at the museum here who are specialized in astronomy. They're actually all part of the Royal Astronomical Society of Canada. And here we've got one that's especially for adults. So we serve tea and coffee, and we talk about a particular topic that you're interested in. So we sort of contact you beforehand and say, do you want to talk about black holes, or do you want to talk about black galaxies, or Venus maybe, or asteroids, or something like that. So these you just book on demand. So we say 10 people, you can have 10 people, but you can have 5 people, you can have 2 people, whatever you'd like. So that's our new program. And then as well, family astronomy and space workshops. We've got one going on right now. If anybody saw some little kids running around in the museum, it's a set of workshops. There's 9 of them in the year, and they're for kids probably age about 4 to 10. They do like a really fun craft, and they learn a little about astronomy, and the whole family is there to have fun. So those happen about once a month as well if you're interested in signing up some younger kids. The next one is on November 25th, and it's a constellation storybook is what they're making. So that's some of the stuff that we do here. We also have youth astronomy programs, so like Beaver groups and Brownie groups and things like that can book their tours on demand whenever they'd like to. And there might be another slide. The next slide is about you guys. And so we're always looking for volunteers to help out at our free stargazings or some of our special events. So this photo that I have here is from Earth Hour 2011. So this is last Earth Hour when we had beautiful skies out. We had it was actually an event that was hosted with Ottawa Hydro Ottawa, and it turned out to be a really, really big event. I think there was over about 800 people here, which we weren't actually really prepared for, but this year we're going to be prepared for it. So we had the telescope open. Tim Cole was in the telescope all night, probably freezing, and we had all of these RASC volunteers in front, sort of trying to calm the crowds as they were waiting impatiently in line, or patiently, I guess, in line. And so we're always looking for volunteers for this kind of thing. And to volunteer, this has been done in the past, but I think it was sort of dropped. So just for sort of to recognize the contribution that you guys have to the museum, we have sort of special volunteer regulations. You sign a book, and then we tell you how many hours you've done at the end of the month and things like that. It's really good for recognition. So if you'd like to become a volunteer, there's a personal screening and consent authorization form. It's like a police background check, essentially, just to make sure. So these are required to volunteer at our events, starting for winter solstice, which is the next one on the 21st. So we'll just have you quickly fill it out, and then after that, you're good to volunteer for 10 years. We don't ask any more questions after that. So if you are interested in volunteering, you can fill one of those out. I'll leave a bunch with Mike Mogadam, but I'm not sure if he's here right now. Yep. Oh, he is. Okay, so he'll have an electronic copy on Monday, I promise. And there's also a few copies here if you'd like to fill one out today. So some of the events that we have here. So you'll see this is Jeff right here, and he's showing his nice presentation to all of these guests at Earth Hour. This was not a RASC volunteer, but I thought it was kind of fun. This is the Hydro Ottawa owl, or something like that, but he is with a RASC telescope. So we have people set up inside and outside, so we're doing outreach with our programs, because as much as we'd like to, we don't have that kind of enthusiasm and excitement about astronomy in the museum, in our employees, as we do in a group like you guys. So you guys make our events amazing and really worth it for our visitors. So thank you to all of the volunteers that already do volunteer, and we're looking for more. So anybody who'd like to come out, just talk to Mike Mogadam or grab a sheet here, and I think he lets you know when the next events are coming. So the next one, winter solstice, on December 21st. We'll be doing stargazing that night as well, so you bring out your telescopes and sort of talk to the public. We have Earth Hour happening in March this year, the end of March. International Astronomy Day in May sometime. And then we have monthly stargazing and public lectures like we had with Terrence Dickinson a couple weeks ago as well. And RASC members are really nice, because that night we knew it was going to be cloudy, and I asked them to come out anyways with their telescopes, and it actually worked really nice. So Jeff, who's going to talk to you about indoor observing, he pulled that one on that night, so it was really great. So thank you very much to everybody. I think that is my last slide. So I'll leave these forms here with you, and you can talk to Mike. Or any of our astronomy educators also know a lot about our programs here at the museum. So Paul Coninger, Brian McCullough, Tim Cole, and Sylvie Leitopno are all astronomy educators here at the museum. They're only astronomy educators, but they know an awful lot about the programs. If you have any questions about them, you can certainly feel free to ask them. Thank you.
Just a comment.
Yeah.
I told you this before in person, but this is the most, in my mind, this is the most best organized astronomy program I've seen at the museum in years. Really, hats off to you. Well done.
Thank you. I'm really excited about this year. I'm so excited. So thank you so much for keeping the partnership going. And now I'll just
Thank you. Yeah. Good. Thank you, Melanie. Okay, and just to close off the first half, before we go for the break, we have our observation reports. Tonight we have two sets of observations, one from Paul Commission and the other Rolf Meyer. So without further ado, I guess we'll skip forward. And Paul, would you like to speak to these, please?
Yes, this is AGC 2065, known as the Corona Borealis Galaxy Cluster. It's a fairly bright cluster as galaxy clusters go. The galaxies aren't too crowded, so you can easily photograph it, as you can see. The galaxies run about 14th magnitude, 14th to 15th, so that means not a very long. Mine is only a 10-minute exposure. The interesting thing about this contains also about 109 galaxies. But the interesting thing is that there's a story that Fritz Zwicky while observing this particular galaxy cluster, derived this missing mass thing, in the 1930s, which we now call dark matter, from this particular cluster. So it's not official, but it's said that this is the cluster that he observed where he got this idea of this missing mass, or this dark matter. This is where it started. Next, please. This is Trumpler 1. Robert Trumpler was a great worker of open clusters. In fact, he has quite a catalog, and in the 1930s and 40s, he did a lot of observations. He's the man that derived the classification system for open clusters. And this Trumpler 1 is typical of the type of cluster that he observed. This is quite small, easily seen. This is near M103 in Cassiopeia. So if you want to know any more, I've got some details on these things that we can talk about if you see me after the meeting. Thank you.
Thank you, Paul. Next up, Rolf Meyer. Welcome, Rolf. So this was Jupiter on the night that it was at opposition, and it's all downhill from here. It's going to get smaller and dimmer, but you can see, interestingly, at opposition, the limb darkening is pretty much uniform around the planet. As we get beyond opposition, the limb darkening will change, and it'll be darker on the others on one side. I think it'll be darker starting on this side from now on. And there's the great red spot just leaving the limb. These are not red spots, even though they're red spots. So that's it. Did anybody else observe Jupiter that night? No, of course not. No, it was terrible. It was a terrible month. I was very lucky to even get this done because it was awful. But Mars is almost getting to be decent now. It's only 5.96 arc seconds, so you can see a fair amount of phase on it. You can see the polar cap. And a little bit of polar cap up there. This is a feature called Solus Lacus. There's some clouds here and another dark feature here. But that's about it. If the scene were better, you could have maybe seen a bit more. But that's it. That was all. Only seven clear nights In October, as Gary pointed out, so I guess that was it. Gary, I thought you'd show your aurora picture. You're not going to show your aurora picture?
Well, I thought it was.
No?
It was in the paper on TV.
Oh, we don't get the paper, so we didn't see it.
Next up, reminder about tickets for the annual dinner meeting and talk. See Gary at the break.
And then moving on, this is something we've had for the last few meetings now. I'm introducing recognition for some of our long-term members with little lapel pins. There's really been no program running up till recently, so I've implemented this to help us recognize people that have been with the center for a while. Last couple meetings, we've handed out 60-year pins, 50-year pins, service and youth pins. This meeting, I'd like to hand out 40-year pins to any of our 40-year members who have been with the Ottawa RASC for that long. One interesting thing that came out, I've been mailing out 50-year pins because many of our 50-year members aren't able to come out to the meetings. And I got a rather sad note back from Dr. Lindsay, who was a 50-year member, had passed away just a couple weeks before he got his pin mailed out to him, and I got a letter back from his widow. So if any of you knew Dr. Lindsay, who's been a life member, I guess, of the society since the 1950s, late 50s, that's a bit sad news. But it's interesting to find all of the members that have been here with us for so long and have been supporting the center for so long. There's quite a, as you can see, a broad distribution. So moving on to our 40-year members, what I'll do is I've got the pins here. I'll mention your name, and if you're here, please come up and I'll give you a pin. So Art Fraser, who's our membership director and has been for about the last 30 years. Art. Donald Bratt. Please forgive my pronunciation of any of these names if I horribly mess up. Peter Ryback. Thomas Ray. Now, I don't know how many of these members are actually life members that joined in their youth and then moved away. That seems to be a common thing as well. Howard Simcover. Okay. Isabella Darenzanko. Rob Dick. Kenneth Heaton. George Dewey. Okay, I know Rolf is here. Rolf?
I was 2 years old when I joined.
No. Dr. J. DeConnick. Brian Burke. Okay, thanks to all our 40-year members. I will be giving out some pins to anyone who hasn't been able to attend these meetings at the dinner. So if you're available there and you've missed, we'll be handing them out there as well. Oops, wrong way. Is that it? All right, thank you.
Thank you. Next up, Bob Olson to tell us about his adventures in the horribly over hot and unpleasant South.
The picture in the screen has nothing to do with the Star Party at all. Oh, right, sorry. It's a 22-hour drive from here down to where the star party is in Chiefland, and I felt that I really didn't want to drive this by myself, so I asked all my astronomer friends if they wanted to go, and I was rejected by every one of them. I have to assume that's because they were employed rather than some personality defect of my own. Eventually, I convinced my wife to go, and she said she'd go if I supplied her with lots of wine, and that astronomers were easier to take when mixed with lots of wine. This is the site we had in Chiefland, and it's actually a wonderful site for observing. My trailer is this one right there, and my scope is the one with the light shield over to do flats. This is an imager part of this field, and they told me that all the wives came down, and that wasn't actually true. They all came down last year. And my wife is not a big fan of these things either. And they didn't come down, and she assures me she's not going down again either. My company wasn't enough. The field is fabulous. It's owned two fields. This guy here owns this field, a guy called Tom Crowley, and down here is a guy called John Novak. And they open their field to people to come and observe every new moon and for 1 week during the fall. They have some pretty nice facilities. The imagers were set up over here. That's because of all our TV screens, so they really wanted to get us away from the visual observers. And they have an air-conditioned clubhouse there, which is really quite nice. It was 85 degrees Fahrenheit during the day, and but cool at night. Got down to 10 degrees one night, and that doesn't sound that cold, but we just about froze to death. Skies were fabulous the first 2 days, just fantastic. And we had clear nights 3 of the 6 nights. 1 night was rain and 2 nights were cloudy, but it was fantastic. This is the view of the field. There was, in past years, there's been between 200 and 300 people come to this, and this year there was only 100, and the organizers of all star parties are starting to wonder a little bit what's going on. They think it might be the economy, but they don't really know. The attendance was way down. That makes no difference to the people at it, of course. This is John Novak, the owner, and this is him adjusting his 36-inch Newtonian that's on a giant fork mount. It's quite a scope. I also wouldn't want to fall off it because this thing here, this level there is about 15 feet in the air already. So if you fell off that ladder, you'd know it. We would image all night, and then these idiots would process all day. And you can tell by the look of this guy, he's been at it for too long. Air-conditioned house, the air-conditioned clubhouse, though, so, you know, it's a little cooler in there. These are some of the images that were taken. This guy was set up next to me, and so I basically borrowed his images to show you guys. This is a fantastic image, I think, just incredible. Guy, a good processor as well as a good imager. He did not enter this in the contest. This one Dean won first in wide field. And he came second in deep sky with the Deerlick. Bubble Nebula and M52 is a DSLR image by John Talbot. John Talbot is a hurricane hunter. He flies into the middle of hurricanes in an airplane. He's a complete lunatic. And he won first place in DSLR imaging with Heart and Soul. And he came first in deep sky with this image of I think this is called the Ghost Nebula. Yeah. He is, as you would imagine, anybody who flies into hurricanes, he's dedicated, compulsive, doesn't think about anything when he's there except imaging. Flying into the hurricanes? Yes, he does. This is his job. I did some imaging, too. This is the first image I took when I was there. I spent the first night setting up my scope. I'm actually a better visitor than I am imager. And so I spent most of my time just wandering around bothering people. One of the reasons I went down there was because I really wanted to take a picture of the Helix Nebula. It's too low in the sky for us to get right here, but it's 15 degrees higher in the sky down there. And so I did the image. This was the image that I was actually going down there for. And it is monstrous. These are two of my other images that I took other times, 57 and 27, and they're the same image scale. So you can see that it is a big nebula. And every morning I would wait till dawn. I was up till dawn. And this is the new moon being chased by the sun up in the sky. And if you just look how blue that sky is. It is just a fantastic sky. One of the conditions of me going was that I had to leave early because my wife, I had a class. And so we left early just in time to run into that nor'easter. And where we spent 2 nights here. This was in Maryland. We crashed into it in Maryland, and we just pulled in. We stayed 2 nights at a resort hotel, so it was really tough to take after those porta potties. We got 8 inches there, 8 inches of snow. All around us got 12 inches of snow, including Highway 81, which is the one we were driving on, so we really couldn't go anywhere. And just northeast of us, they got 27 inches of snow. It was hard to imagine at this time of the year. And next day, 15 degrees Celsius, all gone. Snow was all gone. Some great speakers, by the way, including our own Doug George was there giving a talk. Anyway, thank you very much.
Thank you, Bob. Here we go. Next up, Jeff Cohill will speak to us about indoor observing. You know, when the sky doesn't cooperate, I guess there's another way, isn't there? Is that for me?
No,
Why?
sorry, no. It's a surprise package.
Oh, thank you.
After you see such fabulous astronomy, you're going to find this more a human interest story than earth-shaking in astronomical terms. You may guess that this has to do with outreach, astronomy outreach. And I acknowledge Mike as the impresario, and I'm part of his troupe. Notice I didn't say a trooper, because I'm sure that could be mixed up. But before really moving, I want to thank Chris Terran for his terrific work in making some decent show out of my material. So in an earlier era, you'd be called a prestidigitator, different kind of digits. So if Chris is the pixel pusher, then Eric has got to be the pixel collector. I just want to acknowledge both their work. Now, I should let you know that what you're about to see is a reconstruction of an event. But let's begin by having a further look at the Jupiter in the room. There is the room, and the Jupiter is coming into focus. Now, the real Jupiter you'll see later that I have mounted there, and I just want to, may I have the next slide, please, Chris? This is the lighted Jupiter that I make use of. It's probably something I bought at Princess Auto. It's a 24 light-emitting diode light structure with a beautiful ball and socket hook and a magnetic back on it. And I've assembled this by cutting out a Jupiter from a poster, I think from IYA 2009. I had lots of posters. I need anyone who has some Ektachrome or Kodachrome positive images in film form who wants to get rid of them. I'll be a sucker for making more of these. A small problem in constructing this is that the 24 lights want to show individually, so I had to get into some diffuser tactics, some parts of which you see over at the right. Now, I just want to say that this Jupiter, I conceived and built it last fall, and it had its first airing in October of 2010 at the Science Fun Fest. Oh, God, I'm one slide out. So, no, I'm okay.
back then?
Yeah, go back. I can't read my own notes. So I used it for its first time at the Science Fun Fest, but anyone who was there last year knows that the planetarium drew such mobs of people that anyone else was crushed out of contention. So I didn't hang on very long. The next time was in November of last year, where Gord Webster and I took up Eric Coelho's invitation to join him at the Pierre Elliott Trudeau School in the former Hull section of Gatineau, and it worked rather well. As I'm getting more experience with this thing, I'm learning further tricks. In August of this year, 2011, I put this to use in a presentation that you're going to be seeing in a moment. On the 16th of August, again, it was played successfully at the Science Fun Fest out at Booth Street. On that occasion, we were not inside. There were some solar people. I was part of that outside gang on the most blustery day you could imagine. I have some pictures of that, but you're not going to be seeing them tonight. And finally, just 2 weeks ago, I was part of the Terence Dickinson show with the indoor telescopes that Melanie referred to. So if I may have the next slide, a Jupiter that's that traveled requires a lot of maintenance and backup stuff. So I've got a miscellaneous collection, a blinker that goes under the pylon. I've used one of these picker-upper things, and you'll notice particularly the collection, a sizable collection of eyepieces. Why there is a collection will come out in just a minute. Okay, if I could have well, I thought we put in one more. No, I'm out of order. This is fine. I'm sorry to be bumbling this way. I've been rehearsing this for months, it seems. But this event takes place in the Earl Armstrong Arena in a senior center I've belonged to for many years. I just have to get into character a bit to make the event real. There we are. So we'll go upstairs to the Gloucester Senior Adult Center. This is in the east end of Ottawa. And further up, we'll see the program for, actually, this is the fall program. I told you a lot of this was reconstructed. And now we'll go in, and the occasion is Grandparents' Day. And Grandparents' Day is billed officially as follows: from 10:30 a.m. to 1:30 p.m. on Wednesday, August 4th, Grandparents' Day. Saddle up and come down. Come on down. You can bring your grandchildren and great-grandchildren for a fun-filled day of crafts, lunch, and games, all with a Western theme. Now that Western theme makes some sense out of why I'm wearing this. You'll find that it's not easy to do any telescope work with a hat of this dimension. And here is a grouping of 4 pictures that were taken by our official photographer. He didn't realize I was in a little room separate, and he didn't take any pictures. And when he saw me come in to the main hall for lunch, he thought I'd just dropped in for lunch. No, somehow the communications failed, and he never appeared, which is sad, because I had some beautiful children assembled there, waiting their turn at my telescope. So let's see the room again, please, Chris. And here's the lighted Jupiter mounted up on the plumbing, the heavy-duty plumbing, and the task was to place the telescope to see this. Now, this is not a great distance. For you people who do solar and deep sky stuff, I want you to know that the Jupiter object is 0.27 light nanoseconds from the muzzle, let's say, of the telescope. That's a significant challenge. The object the lights from the rays from the object are not striking the objective lens in the telescope the way they would normally do. They weren't the telescope wasn't designed for anything like this. It's even preposterous to try to make this work. I found out as I was doing it that I did 2 rehearsals and I gave myself the maximum distance, so I was shoved way into this corner of the room. And then when I got there for the actual event, I realized, my gosh, the kids aren't going to have room to get around the telescope. So on the actual day, I moved the telescope closer. Well, that was a fatal error. I couldn't realign it. In fact, I had to go home and grab a larger eyepiece to even get this ready for the children. If we can have the next slide, Chris. So here's one of 3 candid shots that happened to get taken. Otherwise, I wouldn't have any. And you can see that what the young lad is doing is actually operating the altitude and azimuth controls. I certainly didn't explain them by those terms. I said this goes left or right, this brings it up. And he's studying, he isn't particularly, the next one you'll see more clearly, is looking through the finder to get the crosshairs on the object in order then to slew it or what have you to the real thing. I didn't want them to have to start from scratch, so I left it in the field of the finder scope. Now, at this distance from an object, the finder scope proved as big a problem as the main one. Clearly, they're not parallel, their optical paths aren't parallel. And this particular finder is a 9x50 by Orion, and it focuses with the barrel, which seems to me not a common kind of apparatus, but I'm sort of used to it. And then it also has a threaded ring to tighten it up. But in this case, it had to be extended so far that you might say it was hanging on just by a thread. That's supposed to create gales of laughter. Okay. I shouldn't say okay. Here's the next lad, and you can see the professor with his body English guiding the child. Why I wish we'd had more pictures. The children lined up for their turn at this were simply glowing with anticipation. They actually loved it. Many of them went out and made a return visit, and some went out and brought their friends back. And I'll show you one more. Chris, please. And here's a young girl. I brought the stool, and one kid said, you know, we have a stool like that at home. And this is not a grandmother, this is a mother, and I think she got a good focus. So a sense of what they saw is in the next slide. And this is, if this were an earlier era, I'd call this airbrushed. This is the one Chris prettied up. This isn't what they saw really, but it's an ideal approximation. And finally, I've got 2 grandchildren who didn't get to see the Jupiter. That's my little show. Thank you.
Great, thank you very much, Jeff. Very nice. I said outreach comes in all forms, right? Get them started early. So last up here, we have Eric Kulila is going to come up and give us an update on St. Veronique, where he'd been exploring previously. Welcome, Eric.
Thank you. Hello, everyone. Just to give you some background for those who don't know, Chuck O'Dale and I explore impact craters. And we've seen lots of craters through in the last 6 years. And in August of this year, we flew to a site that we thought might be an impact crater. Chuck received an email from someone and a graphic that compelled us to look at this site. Basically, the supposed site is in it's in Quebec, about 2 hours north of here by car, about a little less than an hour by plane. We flew over it in Chuck's Cardinal. So let's see, how does this work here? Can we see okay, there's the laser. So we flew from Ottawa up to this area here called Saint-Véronique. And Saint-Véronique has a feature that caught our attention. If we can go to the next slide, please. This is a photograph I took of the area. We thought it was an impact crater based on the graphics we received. And when we flew up to it, even then we were getting really excited about this place because we thought we may find a new impact site that hadn't been discovered before. Next slide, please. So if you can look at the image here, you'll see this very compelling feature here. You know, that it's round, it's got a ridge, you know, it's a rim. This is the town of Saint-Véronique here, and there's a road that actually goes through it. And that really got us going. So let's go to the next slide, please. So we had this other graphic that we looked at, again, thinking, wow, this could be it. And what made it worse was there was another one. So we were thinking this could be a double impact, kind of like the Clearwater Lakes in northern Quebec, something like that. So, you know, we're flying over this thing and enjoying ourselves, having a good time, telling lots of jokes over our headsets, and enjoyed our filming. We were looking for bedrock that we would then go to in later explorations to see if we could find some real evidence, because something that's round doesn't mean it's an impact crater, not at all. And we would find shatter cones, impact melt, things that are really scientifically proving that it is an impact site. And we got back home, and if we could go to the next slide, please. This is another graphic. This was actually the first graphic we received that you know, really told us this has got to be an impact crater, you know. But as we flew over, all we could see was a lot of sand, no bedrock. And got back home and found out that the site is not an impact crater at all. And we were very careful to not making any assumptions. And we found out actually from our own Simon Hamner here that it is in fact a pluton. A pluton is described as intrusive igneous rock. That's the best definition I've found for it. It's geologic activity. When magma cools, it apparently creates these objects called plutons. There are many kinds of plutons. And this is actually described as a complex pluton. And if we can go to the next slide. Does anyone know what this is? I always wanted to do that. Devil's Tower is actually referred to as a laccolith. Is that the correct pronunciation, Simon? Laccolith pluton. And we have some other plutons we can show you here. These are all examples of plutons. And so I learned a lot about plutons after. And you know, having flown over one, not knowing it at the time, I decided let's find out a little more about plutons and its geologic stuff. It's not impact craters. Very interesting nonetheless, but not what we wanted to find. In science, you never make any assumptions. You always stick to the facts you have before you draw any kinds of conclusions. And it's a good thing we did. I still enjoyed doing the flight with Chuck. I don't regret it. It's better to be out there trying and doing stuff than staying at home and watching the Discovery Channel. So this is what happened. And sorry, folks, it's not an impact crater. It's a pluton. Thank you.
Good. Well, now we know. Okay, so just finishing up, a bit of business to get done before the end of the meeting. First of all, a little bit of surplus equipment from SmartScope. During the renovation, refurbishment, rework that's being done on SmartScope, this is turned up as being an item no longer needed. The center is putting it up on Astromart for sale, but if there is a member who is interested in this, I'm not quite sure who they're to approach. Oh, they can speak to Chris Stern about this and perhaps make an offer on it. So it's basically a motorized focuser, remote control, temperature compensating, and it's a currently available model. It's not something that's out of production. You can buy them new these days. Very precise, very nice piece of equipment, just not needed for SmartScope. So if you're interested, please talk to Chris. Next, please. Okay, Queen's University. So I haven't read this before, but I can read as well as you can, I'll bet. It appears November 17th. We have a talk by NASA astronaut Dr. Drew Feustel. So I'll leave you a few moments to scribble down if you're interested in attending that talk. There's a website that you can check on. I don't expect you to scribble all that down, but if you are interested in the talk, you can come see Chris immediately after the meeting and get the details from him. Next up, Estelle's Pick of the Month for the Stanmont Book Library, Deep Sky Wonders, one of the Sky and Telescope publications. I invite you, as usual, to drop into the book library, rummage around, see what you can find. There's lots of great stuff there. Next up, post-meeting, the book library, I believe, will be open tonight.
5 seconds.
Okay.
5 minutes.
Yep, fair enough. So shortly, it'll be opened up. The Equipment Loan Library, Al is here, spoke to you about it earlier. You should rush right on over and plank down your $50 for basically lifetime ownership of one of the telescopes. You know, sounds like a heck of a deal. And you get to store it at your place too. Okay, coffee and conversation as usual, courtesy of Art and Ann Fraser. You can see them out in the lobby. And I remind you, please don't go into the rest of the museum. The rest of the museum is closed, just the lobby area for us. Membership info, you can speak to Art Fraser. Memberships are done through the national website. I just renewed mine recently, so, you know. We don't fill out forms here or anything like that. However, when your card comes through after you've become a member, you'll go see Art about getting your card, because of course we don't have the hard copy astronauts being published any longer. If you want to look into the discount renewals for Sky and Telescope or Astronomy Magazine, if you're interested in these magazines and would like to get a bit better price, the Society does get discounts. See Stephen McIntyre about that, and he can help you out with it. Again, I remind you, the rest of the museum is closed, and the usual reservation has been made at Kelsey's. So pop on over and join the gang if you'd like for snacks and drink. Attendance tonight, 132. So we're starting to trend upward again. Yeah, you always notice that it falls off during the summer as everybody doesn't find enough light or something. But anyway, attendance usually drops during the summertime and usually rises during the winter until it starts to snow and they all have to stay home or in the ditch. But anyway, it's trending its way upward again. Many thanks to the organizers and speakers, Chris, Gary, Al, Simon, Melanie, Paul Commission, Rolf, Bob Olson, Jeff Cohill, and Eric, of course. Thank you, Eric. Thanks to our host, the Canadian Science and Technology Museum. I would I would say any complaints or suggestions or other things, if they're to do with this meeting or next meeting, you can contact me at bill.meeting.chair@gmail.com. If there are suggestions for further out, you can direct them to your to-be new meeting chair, as of January, paul.cloninger@rogers.com. So with that, I'll remind you, the next meeting is on December the 2nd, so very early in the month this time. It's a swap table, so if you have any, how shall we put this, any no longer needed astronomy trinkets or other things, bring them on down, and we'll have the swap beforehand. So that'll start a little before the meeting. I would suggest being down here for, say, 7 p.m. So you've got plenty of time there. Other than that, same idea. Observations and ideas for talks, there's the 2 email addresses. So thank you all for coming down. Have a safe drive home, and we'll see you next month.